Good morning, students. We are learning about the physics, and the lesson is gravitation. First, we have learned about Newton's law of gravitation. The statement of Newton's law of gravitation is the force of attraction between any two objects on the earth is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That is, F is directly proportional to product m1 and m2 divided by r square, where m1 and m2 are the masses of the two objects which are situated at a distance of r from each other. That is, the distance between their centers is r. Now from this we have find the gravitational constant, universal gravitational constant G. What is the formula of a G? We also prove the formula F is equal to G m1 m2 upon r square. From this we have proved the formula for G is equal to F r square divided by m1 into m2. We have find the SI and SI unit of G also. SI unit of G is SI unit. We have find it is the F means Newton, R means distance, Newton meter square per kg square. This is the SI unit. CGS unit of G is equal to, instead of Newton it is dyne, instead of meter it is centimeter square, per instead of kg it is gram square. Dyne centimeter square per gram square. These are the units, SI and CGS unit of a gravitational constant G. The value of gravitational constant is always a constant. It remains same for each of the planet. Now see, according to this Newton's law, F is inversely proportional to square of the distance between them, that is r square. That is, F is inversely proportional to r square. Now if this is possible when the distance between the two bodies is equal to r. These are the two bodies having masses m1 and m2. Distance between them is r. If we half the distance between the two bodies, this is the distance r, and if we get half the distance between the two bodies, masses remains same. The distance between their center is now r upon 2. Now what will be the force of attraction? In this case, F is directly proportional to 1 upon r square, or F is inversely proportional to r square. Now in this case, F is directly proportional to 1 upon, instead of r, the distance is r upon 2. That is r upon 2 bracket square. Means see what will be the value. F is directly proportional to r upon 2 bracket square. That is 1 upon, its square is r square. 2 square is 4. That is, F is directly proportional to this upon divided by upon, that is 4 upon r square. This force is F1, new force. It is F1. That is, F1 is directly proportional to 4 into 1 upon r square. But we know that the value of 1 upon r square is force F. That is, F1 is directly proportional to 4 times F. From this we can conclude that if we half the distance between the two bodies containing the same masses, or masses remains constant, then the force of attraction between the two bodies gets multiple of 4. Then force of attraction between the two bodies is a multiple of force. It becomes a fourth time. Okay, From this we can conclude that conclusion, if the distance between the two bodies becomes half, then force of attraction becomes 4 times the original force. Okay, this is important for MCQ. Now see, if we have get the distance half, now if we double the distance, what will happen if we double the distance? See, same bodies, masses m1, another body of mass m2, m1, m2. The distance between their centers is now not r by 2, but distance is 2r. That is, if we double the distance between the two bodies, keeping their mass same. In first case, F is directly proportional to 1 upon r square. Now in the second case, what will happen? See, F is directly proportional to 1 upon the distance between the two bodies is 2r bracket square. That is, F is directly proportional to 1 upon 2r square, means the square of 2 is 4. The square of r is r square. That is, F is directly proportional to 1 upon 4 constant into 1 upon r square. That is, F is directly proportional to 1 upon 4. This is for F1. We will say that it is F2. And this force is F 1 upon 4 into F. From this we can conclude that if we double the distance between the two bodies, then the force of attraction becomes 1/4. When the distance between the two bodies is double, the gravitational force becomes 1/4. This is our conclusion. What is conclusion? When distance between two bodies is double, then the gravitational force becomes 1/4. Okay. In this way we can conclude, if we triple the distance between the two bodies, what will happen? See, we can conclude, if we triple the distance, that is, this force is mass is m1, this is m2, and if the distance between them is 3r, then you can easily find the relation F is directly proportional to 1 upon 3r bracket square. That is, F is directly proportional to 1 upon 9r square. F is directly proportional to 1 upon 9 into 1 upon r square. That is, F is directly F2 or F3. See, this is F3, 1 upon 9 into F. If we triple the distance between the two objects, then the force of attraction becomes 1/9. The figure is in the form of squaring figure. Okay. If we double the distance, or if we increase the distance between the two objects, then the force of attraction becomes less. And if we decrease the distance between the two bodies, then the force of attraction becomes greater. Okay, that is the inversely proportional criteria. See one more conclusion. If we decrease the distance between two objects, then force of attraction if we decrease the distance, then force of attraction increases. And if we increase the distance, then the force of attraction decreases. Okay, these are the basic criteria, and in the next period we will see some more things. Okay.